Okay, yesterday you learned how to use the calculator, and you graph with the calculator and you find out that, oh, it touches right here, that's a root. That means you don't have to go through 500 things to test. You don't have to test until you guess and check and finally find it. You can just know from using the calculator. And then that number right there goes into my synthetic, and again, let's just imagine for a moment that we ended up getting this for our answer. Can you stop there, or are you supposed to keep factoring? Supposed to keep factoring. So how do you know whether it can continue to factor or not? You graph this part then. If you graph that part and it's got a root of, let's say, 5, well, then it probably wouldn't be 5. In fact, I know from the rational root that would have to be either 2 or 1, right? Okay, so let's imagine for a moment that it was a 2. I graph this guy and a 2 comes out. Well, then you do the synthetic. 1, I'm going to do the placeholders this time, a 0 and a 0 and a 2. And you just do the whole process over again. Once you've found that this had a root by graphing it, you can do the synthetic on it. And let's say for a moment, 8, 16, 16, 32, 32, holy cow, 64. This one did not work, so it wouldn't have factored with a 2, but if it had, we'd have kept on factoring it until eventually you get an answer like this. Then, after you use the calculator to tell you what to check, you use synthetic. After you do synthetic, it's factored. And after it's been factored, don't forget that the very first thing you took out has to come down, and then you'll have your other two parts. These two give you real roots. This one gives you imaginary roots. Do you know how to do that last part, the imaginary part? I mean, I know you know this part. -3 for this and -2 for that, right? How do you do the last part? Yes, x squared plus 3 equals 0. And now you have two choices. You can either do the quadratic formula. That's good at getting negatives underneath the square root, because that's what imaginaries are, right? Or you can just solve it the old-fashioned way. Move this to the other side. X squared equals -3. Then you do square root on both sides, and there you go. You get square root of a negative. Absolute value of x equals square root of -3. Split that into two things. X equals square root of -3. And x equals negative square root of -3. And then the last thing is you're not supposed to leave the negatives underneath the square root, so I'm going to make that an I. X equals I root 3. And x equals negative I root 3. Okay, plus and minus I root 3. I would like you to tell me if you get this on the test tomorrow. What the real roots are and what the imaginaries are. And I'm going to come around and see if you know what you're doing. So we had -5 for this one, and for this one we had 6. And then the imaginaries, we had to take this part right here, and I'm going to do it the faster way. X squared is equal to -7. I suppose I should show you where that came from. And then I subtract 7 from both sides, and I get this, and I take square root, and then I have absolute value of x equals I root 7, and then I'm going to do the 2. X equals plus and minus I root 7. So there's your two imaginaries. Raise your hand if you had that one right. That's pretty much everybody. Okay, good. All right. I'd like you to actually just go back in time to simple factoring and factor that for me. And tell me what the real roots are. Some of the problems in the factoring test that you're going to have are this easy. And I don't want you to have done so many hard ones that you forget basic factoring. Yep. Once you get the factored form, then the real roots will be very easy. I do want you to tell me what the real roots are. So don't just factor it. Tell me what the roots are. Okay, did you factor it to x plus 1 and x plus 2. Right? Now think about what that means. Could you have done the method I just taught you yesterday on this? Yeah, you could. What would you do first? Graph it. Do it. Grab your graphic calculator, graph it. I just want to show you that this would work even for this kind. Once you graph it, you can either take the -1 or the -2. And then do synthetic on it. By the way, is it a -1 or is it a +1? Where does it touch? Touches at -1? So am I supposed to use, if it's -1, then that's the one that's x plus 1. If the root is -1, then the x plus 1 is the factor, right? Which am I supposed to use when I'm doing synthetic? A -1 or a +1? -1. For synthetic, you take this kind. Now you could also do the -2 if you want, but try it with synthetic ones. Just see it. I want you to see this thing factoring your problem. 1, 3, 2. Right? Drop this down, multiply it, add them, multiply it, add them. Hey, it worked. If you, and when you're done, this thing comes down and I have x plus 1, and this thing turns into an x on this one, and I go plus x plus 1 and x plus 2. There it is. See? Now that would be an incredibly hard way to teach people factoring, but it would work. Okay. One more like that. This time, I don't want you to factor this the normal way. I want you to factor this the new way by graphing it. And then using synthetic. And here's the problem. X squared minus x minus 42. It's the first step. What do you do? Put in the calculator. Then, yep, once it's graphed, you look for what? The zeros. All right. I'll pause for a second while you work that out. All right. Tell me one of the zeros. +7. Right? Okay. That means I should put a 7 like this and go 1, -1, -42. Is that right? Okay. So I'm going to do, drop this down. 1. Multiply them, 7. Add them, 6. Multiply them, 42. Hey, it worked. Final answer, bring this down. X minus 7 times x plus 6. Does it really work? If I do firsts, I get x squared. If I do outsides and insides, I get -x. And if I do lasts, I get -42. Hey, it worked. See? New way to factor. Would that even work with nasty ones? The ones that were kind of hard to factor before? I think it should work for, like, 3x squared plus 9x minus 72, that kind of thing. Should even work for that. All right, so let's do one that's like that. Pause for a second while I make one up. Okay, here's one. Try this one. 3x squared minus 13x minus 10. First job, graph it. Some of you are behind. Tell because you haven't grabbed your calculator yet. I really should set it equal to 0 just to clarify. Okay, once you graphed it, it touched. Can I see your graph quick? Okay, and there. Like there and there, and I think that's the one you wanted. What was that one? 5. Okay, and you go 5, 3, negative 13, negative 10. Drop it, 3. 5 times 3 is 15. Subtract 2. 5 times 2 is 10. It worked. And therefore, x minus 5 times 3x plus 2. That's pretty slick, isn't it? All right. What was the key to the whole thing, though? That you never did until yesterday. The calculator. If you didn't have the calculator telling you what root worked, it'd be pretty tough. All right, last thing I'd like you to see is on the same exact problem, there was another root. Did anybody find this one? It was something point something. Negative 2/3. I want to show you something. Negative 2/3 would have worked too. Let me show you. Put in negative 2/3. I drop this down, and it might not be as bad as you think, because it'll have a moment like this where the 3 times the 2/3, the 3's on the top and there's 1 on the bottom will cancel. So what does that make? Negative 2/3 times 3. You get how those 3's cancel, and what's the answer? I'm doing this times this. Come on now. Those cancel. Negative 2. Add them together. Negative 15. Negative 15 times negative 2/3. Negative 2/3 times negative 15. And then I can do some canceling. 3 goes in here once. 3 goes in here 5 times. 5 times 2. Negatives cancel. Makes it positive 10. Look at that. And it actually worked. And so that means my answer would have been x minus, no, plus 2/3 times 3x minus 15. Do you get that this x plus 2, oh yeah, you're right, the 3 should come out. Oh, what happened there? That's weird. It'll work, it'll be correct, but that's not the way we usually want you to do it, to have some kind of a weird fraction there, but this would multiply out and give you the right answer. We just never have had you had anything except whole numbers here. But in theory, you could do it that way. That's why I just suggested that Joe was pick the whole number, because it'll come out kind of weird if you use the fraction, but it'll still come out. All right. Let's go back old school. Let's make sure you haven't forgotten that. Factor that. It's called difference of squares. If you don't remember this, you're going to miss out on some points. I'd hate that. Turn it my way when you got it. I'll check them off. Check, 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 check. You gave me answers. I wanted the factored. Just give me the factored form. Check, check, check. Upside down, but check. Check, check, check. Can you hold it? There we go. Thank you. Check. Those are 4s. Check, check, check. Okay, good. So here's a little twist on it. 25x to the 4th minus 16. That'll still factor the same way. Perfect squares. You do it the same exact way. You just got to take the square root of that 25x to the 4th. Still factors the exact same way. All right, I'm seeing a lot of different answers on this one. Okay, now they're mostly coalescing on the right answer here. Okay, 5x squared and 5x squared. A lot of people forgot the squared. And then this is a plus and a minus, and then it's a 4 and a 4. Raise your hand if you had that one right. Okay, good. All right. That's called difference of squares. How about this kind? 5x to the 3rd plus 15x squared minus 2x minus 6. Do you remember factor by grouping? That's also a good tool. Now, we're not going to say you can't factor by grouping. You had to use your graphing calculator. You can graph it any way you want. So if you see this and you can factor it by grouping, awesome. You don't have to graph it and find a root and do synthetic and all that stuff. Or could you, if you wanted to? Yeah. Calculators allowed in this quiz, so. Mrs. T, how do I start? Five x squared goes into it, and what do you got left? Excellent. And then on the other one, what comes out of both of them? Good. And what do you got left? Excellent. And since those are in common, then you bring them together and say x plus 3 and put that in front. And then whatever's left over, that and that, 5x squared minus 2. Raise your hand if you had that one right. Awesome. Okay. Would you have any imaginary roots? I've heard yes, I've heard no, and I've heard maybe. How about this? Would you agree that's just a real root of negative 3? Okay. This one, 5x squared minus 2 equals 0. That's how you start. And then as soon as I move that 2 to the other side, you know your answer. As soon as I move that 2 over here, will there be any imaginary roots? No, because I don't have to take the square root of a negative. Since I'm not taking the square root of a negative, I'm going to get real roots again. They're just going to be square roots. They're just not negative underneath them. So let's finish this. Divide by 2, or 5. Divide by 5. And now take the square root. Square root of 2/5. But I got to remember to do plus and minus. X equals plus and minus the square root of 2/5. Just to clarify, those are not imaginary. They'd only be imaginary if there's a negative underneath them. Really common wrong answer on the test. There's a spot for reals. There's a spot for imaginary. Kids will know the real ones, 5 and negative 3 or something. But then the imaginaries, they sometimes get confused and they think that every time there's a square root, there's an imaginary. It's not true. So if any kid ever wrote an answer like this, I'd have to say, nope. That one's actually probably have 2 answers like that. Usually if there's a square root, there's 2 of them because you have the quadratic formula, and usually there's a plus and minus going on. Okay, so my point is, that would be a wrong answer because the kid put this in the imaginary slot, and that's not imaginary. Get what I'm saying? Check your answers. Don't do that. Only put things in the imaginary blank if you had a negative under the square root. So, imagine for a moment, that you had this. Tell me what you should simplify that to and whether it's imaginary or real. What do you simplify that to? And is it imaginary or real? Good. Imaginary or real? Just write an I or an R next to it just to keep it quick and simple. Yes. 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 How'd you guys turn into my smart class all of a sudden? Nice job. Good, 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 good. We got some new recruits in second semester that are bringing up the average. That's good. Good, good. All right. Third hour has usually been my genius hour. They're still like, holy cow, they beat you in every test. Let that bother you, and then try to overcome them. That would be great. All right. So You go plus and minus still, and then it's root 9 and root 3, and then what other root do I have? Root of -1, and that's going to make the I. So then plus and minus 3, and that's an I, and then root 3, and there we go. And that was imaginary. It's got an I in it, so it should be obvious. But I'm telling you, I have a ton of kids who are going to put the answers just because it has a square root in it. They're going to leave it in the imaginary blank, and it's not right just because it has a square root. It needs to have a negative underneath it to then now that's imaginary. Okay, I think you are going to do pretty well on this test. You notice I didn't do a lot with the really big ones just because we did so much of that yesterday. And the really big ones, my advice is see if you can factor it by grouping first. But if that won't work, grab the calculator, figure out a number that works, and then do synthetic to break it down. All right. So your homework for today. There is two things. Number one, a lot of you did not finish the homework quiz that you were supposed to do yesterday. It was number 3. If you haven't already done that, do it. Okay, that's going to go in the grade book. Number 2, your assignment for today, there is a worksheet assignment for today. Let's find it in Schoology so you can know what I want you to do. And I think that's all I have for the video for today.